Okay, so the topic for today is partial fraction decomposition. So that's what I had sent in the WhatsApp group for you guys to be aware. And I was tempted to start unit 3, which is dealing with complex numbers, but in between I got a request for partial fraction decomposition, so we'll do that one. And it sounded like an interesting topic, so that's why I thought we'll cover that first and then we'll go to complex numbers. Will that be okay? Alright. So if I hear nothing, that means yes. I will take that as a yes and move on. Yep?
Yes.
Okay. So when you talk about partial fraction decomposition, what is that you guys know conceptually? I mean, at a very high level, what do we mean by that? What are we trying to achieve here, and why do we even need to do this? Any thoughts? No thoughts? Okay, then let me share my thoughts then. So, let's say if you have a situation where you have something like this, let's say plus 2 by x minus 5, something like this. You know how to do calculation, right? It's like adding two fractions and then you will say, okay, fine, x plus 3 and x minus 5 is going to be my denominator, and then this one x minus 5 multiplied by x plus 2 multiplied by x plus 3. This is how you are. When you have to add these two fractions, this is what it will become. Correct? What we are talking about is decomposing a fraction. When you have something here you are decomposing. You are what is the reverse? What is the opposite of decomposition?
Composition.
Composition, yeah. So here you are doing composition. You are adding two fractions and getting this. So now we are talking about a scenario where we want to do a reverse of this. So let's say if I have something like x plus 5 divided by x square plus 15x plus let's say 56. So if I have this, what we are trying to do is we are trying to decompose this and convert this into a simple form. A divided by something plus b divided by something. Let's say, let me put a standard form for this one. So we are trying to break this into something like a divided by, let's say, x plus a, small a, plus b divided by x plus small b. We are trying to decompose this and convert it to a simpler form. Now you will say, why are we messing around with this? It's just one fraction. Why do we have to break this down? Now the thing is, this is a pre-calculus class. This is a preparation for us to learn calculus. When you deal with calculus, when you have a fraction like this, you will break this into smaller pieces and then you can do things like differentiation and integration. I'm not going into that right now, but in simplest form, our main objective is to break a fraction into smaller or easier fractions so that we can deal with the calculation that will come across. So, and the lame definition of this will be, we have a fraction, we are trying to decompose that into simpler fractions. That's what is called, that's the premise of what we are trying to learn today, which is called partial decomposition of fraction. And again, when we say partial, we are not even trying to break it down into something like a divided by x plus b divided by x plus c divided by x plus something, or plus d divided by, let's say, 4. We're not trying to decompose it to that level. That's why it's still a partial decomposition. You still have an opportunity to break it down further, but we are not going that far. We are just trying to decompose that to get to a simpler state as we can. Is that setting the right context for us to get started? No response? Not a very interesting thing? Arya, Dev, Dhanushri? Are we good to get the ball rolling?
Yes, sir.
Okay, alright. So now let's look at a scenario where I have something like this divided by, let's say, x squared plus, let's say, 18x plus 72. I have to decompose this to bring it to a simpler form, which I am saying which would be x plus a plus b divided by x plus b. And this is a simpler form than this. That's what we are trying to decompose this into. Now, couple of thumb rules that we have to be aware. That when you decompose this into a partial fraction, you have to always remember that your denominator has to have a higher degree. Meaning, higher degree of the variable. Let's say, if you decompose this, it becomes, or before we go there, when we are trying to decompose this, the first thing you have to check what is the highest degree of the numerator and what is the highest degree of the denominator. If you see that the numerator's highest degree is smaller than this, then it's a proper fraction. And then you will go ahead with the next step that we are going to learn now. If this is let's say this was x cubed, then this is improper fraction because the maximum power to the variable is 3, here it is 2. So this is improper form. That will be dealt with in a different way. So the first thing that you have to always look for is whether your numerator's highest degree is smaller than this one or not. And that is when you will call it a proper fraction, and then you will get going with the next steps. Is that thumb rule okay? So here when we saw this one, we saw that okay, the highest degree of the numerator is less than this one. So we are good to get started. Now we are trying to get to this stage. Now before we do that, first thing you have to do is, we have learned quadratic equations, right? How to deal with quadratic equations, how do we factorize them. So your first attempt has to be to factorize the denominator. Let's look at the denominator. Now x squared plus 18x plus 72. Is this in the form of a plus b whole square? No, we cannot. If this is x is a, this is not a square. So this is not a plus b whole square form. So then we have to go to the second approach where we multiply the standard form, where we multiply a and c and then split b into two parts so that it's equal to the multiplication of a and c. So here in this case, a and c are 1 and a is 1 and c is 72. So multiplication of a and c is equal to 72. Now if you look at how do you break 18 into two parts to get 72, or you can say, let's look at the factors of 72. So you can write 72 as 2 into 36, 4 into 18, 6 into 12, 8 into 9. I think that's it. Now, among these combinations, which one you can add to get a B? This is your obvious pick. 12 plus 6 is 18. So, you see that this can be rewritten as x squared plus 12x plus 6x plus 72. I have just combined, I have just split 18x into these two pieces, so that I mean applying the second approach for quadratic equation. So now let's see, if I take x, if I keep these two together, I can say x plus 12 and here when I take these two together, I can take 6 common, it becomes x plus 12. So it became x plus 6 multiplied by x plus 12. So I got the factors, I got the denominator factorized as this. So then this becomes x plus 6 into x plus 12. So this becomes 3x plus 5 divided by x plus 6 into x plus 12. So now I have the denominator as factors. So then we can apply this format, and then we'll try to find out what is the value of a and b. Now this part is clear. I have one factor as this and another factor as this. So let's assume that this equals a divided by x plus 6 plus b divided by x plus 12. And so far we don't know the value of a and b. Okay. So we have just, what we have done is, we have looked at the first thing we checked was whether my numerator has degree, what's happening with the AI? Okay, whether my numerator has a degree smaller than the denominator. That was the case, so that is how we started. And the next thing that we are doing is, we are splitting the denominator or trying to factorize the denominator, and we got this. So we are saying that fine. Now we've got two factors here by converting this denominator into the factor form. So this is what we have got. So this will be equal to this. And so far we don't know the value of a and b. And as part of this whole exercise, this is what we will try to find out. Now if you compare these two equations, what does it mean? Let's calculate this. So this becomes a times x plus 12 plus b times x plus 6. And I'm not doing anything fancy, okay? I'm just adding two fractions here by applying whatever LCM and simple addition formula that we know. So I assume the numerator to be a and numerator to be b here by splitting this into this form, and then I'm doing the calculation. Are you guys okay are you guys with me so far?
Yes.
Arya and Dave?
Yes, sir.
Okay.
Yes, sir.
Okay. Now, so that means my equation that was 3x plus 5 divided by x plus 6 into x plus 12 has become this. And so far we don't know the value of a and b. Okay. So we have just converted this into this form. And once we get the value of a and b, we will substitute that, and that will become my fraction. Yeah. So we just assume this to be a and this to be b, and then we are just comparing these two, the earlier form of the equation versus what we have assumed. Now, since my denominators are same, that means we can say 3x plus 5 will be equal to a times x plus 12 plus b times x plus 6. Yeah. So this is my derived equation where a and b are still unknowns for us. So from this one, now what we have to do next is, we have to assume, see this is like a contract. This is an equation that we have got, a linear equation. Now this is a contract between x, a and b to get this value. Now what we will do is, there could be multiple values of a and b and x. So let's assume some values of x to see what will be the corresponding value of a and b. So let's try assuming a value of x where when I can knock off a, then I will get the value of b. And same way, we'll assume some value of x in a way that I can knock off b, then I'll get a corresponding value of a. So let's do this. So I'm still not erasing everything because we'll use that for reference. Now if I look at this equation, what do I do to make the value, this part of the value as 0? I can put x equals minus 12. If I put x equals minus 12, what happens? When I put x equals to minus 12, so this becomes 3 into minus 12 plus 5 equals, this part becomes 0. So a into 0 plus b times is, in place of x I am putting minus 12 plus 6. Okay, so this part is 0, so I will knock it off. Now it becomes, okay, and 3x, x is minus, okay, 3 into minus 12, sorry, this is into, I was reading this as minus x. So this becomes minus 36 plus 5 equals b minus 12 plus 6, so minus 6, so minus 6b. So this is minus 36 plus 5 is minus 31 equals minus 6b. So value of b becomes 31 by 6. So now if you look at what we have done. First thing, look at the equation that we have to factorize or find out partial fraction. First check the power of the numerator, the degree of the numerator, which was less than the denominator, so we are good to continue. And then what we did was we looked at the denominator and tried to factorize that. So based on our understanding of the quadratic equation, we could factorize this into this form. And we are saying that, okay, let's assume this can be split into two parts like this, like the standard form that I was saying, right? So that's what we assume, and we put a and b as a numerator. And all that we are doing after that is to determine the value of a and b. So now, since these are the equations, so this is, if I am taking this as the fractions, then this is what it calculates to, and we got this as a derived equation. So from this we are trying to find out the value of a and b. So we assume the value of x in a way that this part becomes 0, this part becomes 0, and so that we can get the value of b, from which we got the value of b as 31 by 6. Now we got the value of b, so we have to find the value of a. What we can do is, if we can nullify this or make this 0, then I can get the value of a correspondingly. So what we'll do is, to nullify this, again, if you put x equals to minus 6, then this part becomes 0. So let's say when x equal to minus 6. So this becomes 3 into minus 6 plus 5 equal to a times minus 6 plus 12 times b into 0. So I'll not even talk about that. So this becomes minus 18 plus 5 is minus 13 equal to a times 6. So a equals minus 13 by 6. So now you got the values of a and b by assuming different values of x to simplify this. So now in place of a, you can put this as minus 13 by 6, and in place of b, you can put 31 by 6. So by doing this, now we were successfully able to create the partial fraction of this equation. So this becomes, my solution to this becomes minus 13 by 6 into x plus 6 plus 31 by 6 into x plus 12. So this has become our two partial fractions after decomposing this fraction. So let me take a pause, a moment of silence. Are you guys with me so far?
Yes, sir.
Yeah? Dave? So if I use the acronym, right, of your names, Dhanushri, Arya and Dev, DAD, dad. Bad joke. I call it dad jokes. So anyways, so net, this was our objective. This is what we have done to break it down. Now this is one scenario. So this is simple partial decomposition. Now if we talk about another scenario, let's say. So far you are with me, right? Now let's talk about another scenario where I'm talking about 3x cubed minus 4x divided by x squared plus 2x minus 8. Now the first going in position for us was that is my numerator of higher degree or lower degree than my denominator. Here I see a completely different situation where my numerator is of higher degree. That means this is improper fraction, meaning this value is probably more than this. So something like this, right? If I have 6 by 13, this is a proper fraction where my numerator is smaller than the denominator. If I have 18 by 13, this is an improper fraction, and this converts into this. Right? Same will be the case here. Now what we have to do is we have to again split this out, meaning we have to divide this by this. So let's divide first thing. So we are trying to divide. I don't know if we will have enough space here or not, but let's say 3x cubed minus 4x divided by x squared plus 2x minus 8. Now, if I multiply, what do I multiply with this to get a 3x cubed so that I can knock up the first term? So I will do probably 3x. If I multiply with this by 3x, this whole equation, it becomes 3x cubed plus 3 into 2, 6x squared minus 3 into 8, 24x. So now when you subtract this 2 gets knocked off, so this is 0, and this is 6x squared, so this is minus, here there is a minus here, so this is minus 6x squared, and this minus becomes plus, so minus 4x plus 24x plus 20x. Okay, so you got minus 6x squared plus 20x. Let me knock out 0, that creates confusion. Now, can we still divide it? Okay, yeah. What I can do is, I can do minus 6x minus 6 actually if I do, it becomes minus 6x squared minus 12x plus 48. Now when I subtract this becomes plus, this becomes plus, this becomes minus. So now this got knocked off. Now I have 32x minus 48. So this becomes my remainder because now my degree is smaller than this. So I can write this equation as this. This becomes 3x minus 6 3x minus 6 multiplied by x squared plus 2x minus 8 plus the remainder, which is 32x minus 48 divided by x squared plus 2x minus 8. So essentially that means this and this cancel out. I have one. So okay, before I make it more confusing. So this is your higher degree, this is a lower degree. So what we are doing is we are simply doing, this is a classic scenario of improper fraction. So we are just dividing this by this to find out what is my result and what is my remainder. So this is my result. So by dividing this by this, you can straight away say that okay, by dividing this I got this as my result plus this as a remainder. Plus this as a remainder. So this remainder by this. So you got one partial fraction and then this one to solve. Are you guys with me so far?
Yes, sir.
Okay, so I'm not doing anything magical, okay? If you think that I'm doing partial fraction or anything fancy right now, I'm not. I just had a numerator and a denominator. I'm just dividing it because I saw that this is improper fraction. So by dividing this, this is the result and this is the remainder. So this becomes this, like in the case of this, we got this as 1 5 by 13. So you can as well say 1 plus 5 by 13, right? So that's what it is. That's what it is. Yeah. So now once you got this to this situation, then you are talking about the same stuff. Like we were dealing with the regular fraction, regular partial fraction scenario. So the same thing you will do now. You will break this, factorize this, and then you will convert to a by something plus b by something, and then you will solve for a and b. So let's do that quickly to revise what we have done. So again, we are trying to factorize this. This part is simplified. We don't have to touch that. Now look at this. So how do you factorize this? So again, it is not a plus b whole square, a minus b whole square form. Now you simply multiply a and c. A and c gives you minus 8. And how do you get it? So it's 4 into 2 or 8 into 1. These are two scenarios. Now which two factors you can add or subtract to get a b? So you simply see that okay, it's minus 8, and to get to 2, you can as well do 4 minus 2. That will get you to 2x. So then let's do that. And again, multiplying 4 and minus 2 gives you minus 8. So you are fine. So this becomes, I'm not touching this part, I'm just concentrating on this one. So 32x plus minus 48 divided by, this becomes x squared plus 4x minus 2x minus 8. So it becomes 32x minus 48 divided by, I'll take these two together, so x common, x plus 4, and here these two together, I'll take minus 2 common, it becomes x plus 4. So this becomes 32x minus 48 divided by x minus 2 into x plus 4. So now I got this in the same form like we were dealing in the first problem, right? I got something divided by two factors. So I can convert this into a divided by x minus 2 plus b divided by x plus 4, and you can solve it the same way. Calculate this and compare, substitute value of, again you will substitute two values, right? One case when you will put x equal to 2, this part becomes 0. In another case you will put x equal to minus 4, this part becomes 0, and you can solve it for a and b. So is this part clear so far? If you look at what we did with the first problem, the first scenario versus what we did with the second scenario, what was the main difference? In the first scenario, it was a proper fraction where your numerator's degree was smaller than the highest degree of the denominator. Or rather, highest degree of the numerator was smaller than the highest degree of the denominator. And you just went ahead with this approach. You took this, you factorized the denominator, and then you mapped it with the standard form, and then you compare the two equations, substituted value of x to get a value of a, and second scenario substitute the value of x in a way that another term becomes 0, and you got the value of b as well. Are you guys with me so far?
Yes, sir.
Am I going way too fast?
I understand it, sir.
Okay. How about you, Dave? You have been quiet. You got tired of my dad jokes, is it? Yes or no? Dave, are you with me?
Yes, sir.
Okay. So there are two scenarios. One with the proper fraction and another one is with the improper fraction. And we solve both of them. Now, and net objective is to find or decompose a fraction into simpler form. Now let's look at a third scenario where you have a recurrence scenario, meaning you have something like, let's say 2x plus 4 divided by x cube plus 6x squared plus 9x. Okay. So here again, first check, highest degree of the numerator is smaller than the lowest degree of the numerator. So the highest degree of the denominator. So this check is fine. So we are okay to proceed. But what do we see here? Before we try solving it, let's look at it. Like x is common across all of them, right? So x, if I take out, it becomes x squared plus 6x plus 9. Now, again, so x squared plus 6x plus 9, this seems to be a plus b whole square case. If I x plus 3 whole square will be x squared plus 2 3 is 6x plus 9, 3 square. This is x plus 3 whole square scenario. So that means okay. So that means we have still not started doing any calculation. What we are doing is we are trying to look at what we know versus what we don't know. So this becomes x plus 3 whole square. Now you have a square below. So you have one part is this and other part is square. So when you are trying to solve this kind of equation, you can always break it down into a form like a divided by x plus, now look at this part is power 2, and the most ideal case is when your numerator, the maximum degree of the numerator is 1 degree less than the maximum degree of the denominator. So you can, instead of doing this, am I doing it right? Yeah. So you will do it like this. You can break it down like this. So when you have power of 2, right, you will always look at how do you decompose this into 3 parts, because eventually, see, if you look at this is a cubic equation basically. This is going to result into 3 solutions. So that's why you would always look at breaking this into 3 parts. When we are dealing with a quadratic equation, we were breaking into 2 parts because we know that any quadratic equation can give us up to 2 solutions. Since we are talking about a cubic equation here, you will break it into 3 parts. And again, A, B and C are unknowns. Okay. So you are just assuming that this is how it's going to be. So everything remains the same, nothing changes. It's just about how do you visualize the future state of the equation, and then you can find out A, B and C values, and you can substitute that will give you this thing. So let's look at it. So this becomes 2x plus 4 divided by x into x plus 3 squared equals a times x plus 3 squared plus b times x times x plus 3 squared plus b times x plus 3, sorry, plus c times, this is your denominator, so this is c times x divided by x plus 3 squared into x. Now again, once you come to this point, you don't have to do anything fancy here. You have to just find out the value of a, b and c. But how will you do it? You will assume some values of x so that maximum thing gets nullified. Let's say here, if you have to find out the value of, if you have to nullify 2 of the variables like a and b, if you get this value to 0, this and this a and b gets knocked off. So let's say x equals minus 3. What will the value of c then? When x is minus 3, so 2 times minus 3 plus 4 equals, this is 0, this is 0, so this becomes c into minus 3. So this is minus 6 plus 4 equals minus 3c. So minus 2 equals minus 3c, c equals 3 by 2. So you found the value of c. Now, how you can make between these, in this equation if you see, how you can knock off two of the variables, or how you can make the value of two variables 0. If you put x equals 0, this will get knocked off, this will get knocked off. So when you put x equals 0, let's see what happens. When you put x equals 0, this part becomes 0 plus 4, 4 equals, these two are 0, these two are 0 now. So this one becomes a times 0 plus 3 squared. So 3 squared, a times 9. So a equals 4 by 9. So you got value of a is 4 by 9, value of c is 3 by 2. Now when you look at this, what can you do to get the value of b? So you don't have to do anything actually. You got value of a and c. You can substitute the value of a and c in this equation and then you can find it out. Let's say a is 4 by 9 and c is 3 by 2. So if I, okay, so this is a, sorry, this is a and this is c. So in this equation, 2x plus 4 equals a is 4 by 9 into x plus 3 whole square plus b is not known yet, x into x plus 3 plus c is 3 by 2 into x. Now you can solve this equation, okay? So this is 2x plus 4 equals 4 by 9, okay, this is going to become big. So 4 by 9 multiplied by x squared plus 9 plus 6x plus b times x squared plus 3bx plus 3 by 2x. Now look at this. On this side you have no value for x squared. So that means whatever is the value, total value of x squared, that is 0. So you have 4 by 9 x squared plus bx squared. And this equals 0 because there is no x squared on this side. So you can say 4 by 9 x squared equals minus bx squared. So this, you will say b equals minus 4 by 9. Yeah. So again, I might have put sincere attempt to get you all confused, but a summary of this, that if you look at it, first thing that you have to keep in mind is when you are trying to find out the partial fraction, you have to always make sure that you are dealing with a proper fraction or improper fraction. If you are dealing with a proper fraction, then you can just continue. What will you do is, you look at the denominator and try to factorize that. Once you factorize the denominator, then you will simply ignore the numerator and you will say, okay, this equals a by one part of the one factor plus b by another factor. And then you try solving it for a and b by assuming value of x in a way that one of the part of the equation is nullified. So that gives you value of a. Similarly, you will assume the value of x in a way that the value of a gets nullified so that you find the corresponding value of b. If you are dealing with a proper fraction. If you are dealing with improper fraction, the first thing you will do is split them into a real part, not real, I would say the full number plus the fraction part. Basically, you will divide and find out what is the answer and what is your remainder, and then the answer becomes one part which is already partial fraction, and then the remainder divided by the denominator will be a second part. So you split that to take out the fraction and then I'm just missing the term. What do you call? If you have An improper fraction, you have a whole number and you have a fraction, right? So you take out the whole number part and the fraction part is what you will factorize further. So that is the improper fraction. And third scenario is when you have a repeating term or a square term in the denominator. So in that scenario, you don't go with a by this plus b by other fraction. You go with three parts to it. One is with the first factor, second is with the factor without a square, and third is with the variable divided by the square of it. So these are the three variants that you would need to be aware of, or you would need to deal with. Is that part clear conceptually, or your teacher has just been blabbering for last 42 minutes? Are you guys with me so far? Can we try solving one problem? I want to see if I was able to teach you guys okay or not. Yeah? Can we?
Sure.
Okay. So you have 4x minus 7 divided by x squared minus 36x (11x plus 28). So I would want you guys to factorize and give me two partial fractions for this one. I mean, I'm pretty much done with what I have to teach you guys. That's why I'm trying to use the time to see if we can do a little bit of practice. So can I assume that everybody is trying to solve this? It's okay. I mean, see, teacher talking for 15 minutes and then assuming that you guys have all learned it is not the right statement, right expectation. So I'm just trying to see if I was able to give you guys a path. At least you guys start and we'll see where you are getting stuck. And then we'll try solving it together. So Arya, Dev and Dhanushri, are you all trying?
Yes.
Okay, wonderful. While you guys are trying, I'll just pick one call, okay? Just a minute. कहाँ पे हो? तुम बोले आओगे क्या ऐसे बोला? तो नहीं अभी चल रहा है मेरा क्लास में 15 मिनट है उसके बाद बताओ. हाँ ओके ठीक है चलो बाय. So what's the news? Are you guys done? Still doing it? Dhanushri, any luck so far?
I'm still working on it.
Okay. How about you, Aryanta?
I'm still working on it, sir.
Okay. Sorry if I'm nagging, but yeah, just checking. Okay. I'll give you guys 5 minutes of peace of mind, and then we'll try solving it together. Dave, are you trying as well?
I got one answer.
Okay. How about Arya and Dave?
I'm not really sure about my answer.
That's okay. See, the credit is for making the attempt, because again, I'll tell you guys honestly, okay? So Dhanushri, can I disclose a secret? So Dhanushri was the one who asked me to pick up this topic, okay? So, I mean, without waiting for Dhanushri to say yes, I went ahead. So when she gave me this topic, right? So I have dealt with these things long time ago. So I had to spend kind of half an hour to brush up those concepts and then come to the class. So, and when I was doing it, right, so you could see how much was my ease while solving it, right? I was literally solving few problems. I was just making it up on the fly and I was trying to solve it, because I just brushed up my concepts on the three types, and then I was practicing few sums to be able to solve it. So the summary of what I said is, any concept that you learn, you will have to practice, and you'll have to literally play with it. Okay, I was literally playing after coming back from office. I've not changed my dress yet. After coming back from office, I was just sitting and I just looked through the concept one more time, and then I was solving few sums so that when I come for teaching you guys, I don't fumble or get stuck. So you will have to do the same thing. Okay, if you want to make these concepts yours, this is exactly what you'll have to do. So now I will solve it. Okay, and I would want you guys to compare that with what you did and where you might have gone wrong. So I will repeat myself with the same concept and do it step by step. My first step is fine. Again, a boring concept for you guys, right? Trust, this is given. Read, analyze. So I'm reading it. 4x minus 7 by x square minus 11x plus 28. Okay, this is what I have to factorize. I've read it now. I'm analyzing it. First thing is, okay, this one has power, maximum degree is 1, this one has 2. This is a proper fraction. So I can go with the normal approach. And now I'm thinking, okay, how do I do it? Okay, I have to first factorize the denominator and then break this into a by one factor plus b by another factor, and then simplify it for a and b. So my blueprint is ready. This part is done, this part is done. Now I'm recalling Nike. Let's just do it. So now it's a Nike's turn. And I have talked about Nike so much so that I was tempted to buy one Nike shoe. So I got a Nike shoe for myself a couple of weeks ago. Alright, so coming back to the serious business. So now we know that we have to first factorize this. X square minus 11x plus 28. What is my A and C? 28 and 1. This gives me 28. How do I factorize this? I can do 2 into 14. I can do 4 into 7. I can do 14 into 2. There are 3 factors that I can think of, apart from 28 into 1. Now, among these factors, which 2 I can pick, which gives me an 11. So I can pick 4 and 7 to make it 11. And since I have to get a minus, so I can do minus 4 and minus 7, which becomes minus 11. And minus 4 into minus 7 is 28. So yeah, math is in place. So I can break into minus 4 and minus 7. So that's my backend calculation. It tells me that I can say 4x minus 7 divided by this as x squared minus 4x minus 7x plus 28. I can pick 2 together, so it becomes 4x minus 7 divided by x. Here I can take x common, so this becomes x minus 4. And here I can take minus 7 common, which becomes x minus 4. So I got this, which becomes 4x minus 7 divided by x minus 4 times x minus 7. Did you guys get to this place? Up to this much? Because whatever we learned with respect to quality equation, that is what we have applied to factorize this. Yeah? So far, nothing done for partial fraction decomposition. Okay? So far, we have just dealt with quality equation. Yeah? So now I got this. So now with whatever we have learned, we can say this equals a divided by x minus 4 plus b divided by x minus 7. And so far we don't know the value of a and b. That is what we are going to determine. So all this circus and drama that we have done, or that I have done so far, translates into a divided by x minus 4 plus b divided by x minus 7. Okay, so now let's look at this guy. So this simple fraction addition, so my denominator will be x minus 4 into x minus 7, and it will be a into x minus 7 plus b into x minus 4. Yep. Now let's break the brackets. Ax, or let it be like this. Let it be like this. Plus b into x minus 4 equals 4x minus 7. Because my denominator is same, so I'm just keeping it out of the equation for a simple looking equation to deal with. Now here, what we'll do, we'll assume value of x in such a way that one of the element of the equation becomes 0. So if I put x equals 4, this part disappears. If I put x equals to 7, this part disappears. So let's pick a scenario when I am putting x equals 4. So when I put x equals to 4, this becomes 0 into 4 into b plus a times 4. We are putting x equals 4. 4 into 4 minus 7. A times 4 minus 7 plus this. So this becomes 16 minus 7 is 9 equals 4 minus 7 minus 3. So minus 3a. So a becomes 9 by minus 3. Minus 3, which is minus 3. So we got the value of a is minus 3. Now a we got as minus 3. Now let's assume a value of x in such a way that this part becomes 0. So we'll put x equals 7. So when we put x equals 7, this becomes 4 into 7 minus 7 equal to, this part becomes 0, a into 0 plus b into 7 minus 4 into 3. So this is 4 into 7 is 28 minus 7. 21 equals 0 plus 3b. So b equals 21 by 3. So we got b equals 7. So we got b equals 7 and a equals minus 3. Now we have a solution here. So we will substitute a with minus 3 and b with 7. So this becomes a equals minus 3 divided by x minus 4 plus b is 7 divided by x minus 7. So did you guys get to this point, or there was maybe something missing in between?
I got that as well.
Okay. Arya and Dev?
I'm good, sir.
Yeah. Okay.
Yeah, good.
Okay. So basically, see, whether you do one problem or 101 problem, concept remains the same. So whatever we did was just an application of the concept that we had looked through. So that being said, this was the whole premise of what we were supposed to learn as part of partial fraction decomposition. So we decomposed fraction. We learned 3 techniques. One is simple proper fraction, improper fraction. When you have improper fraction, you first divide the numerator by the denominator and split that into the whole number and the fraction. And then when you have the fraction part, where your numerator becomes smaller and the maximum degree of the numerator becomes smaller than the degree of the denominator, you deal with that the same way like you dealt with this one. And the third situation was when you had a square or a repeat in your denominator. So that is where we saw something divided by x into x plus 1 square or x plus 2 square, whatever it is. So when you have a square in the denominator, it splits into 3 parts, a, b and c. So a by 1 factor, by b by just the factor, and third is b, c divided by x plus 1 square or x plus 2 square, whatever is the square basically. Yeah. So that is the summary of all that we have to learn. My request to you all would be practice, get your hands dirty like mine, and then that will become yours. Are you good?
Yes, sir.
I hope whatever I said was easy to understand. If not, you have a second opportunity by watching the video, and if that is still not working, let me know. Alright? I'll let you guys go. Enjoy the rest of your evening. Have a good dinner, good night's sleep, and talk to you guys after the new year, because next week I'll be traveling most of the times, and I'll be back to Dallas by 2nd, which is one day before your class. Okay, 2nd is what? 2nd is 2nd a Wednesday? So let me check.
It's a Thursday.
2nd is a Thursday. Yeah. Okay. So essentially, we will have a break of 1 week, Let me see if I can figure out a way to do a class on Thursday or Friday. If not, we will do it in the second week of January. Yeah?
Yes, sir.
All right. Enjoy your holidays. Stay safe. Have fun. And don't forget me. Once we are back, we'll resume.
Okay, thank you, sir.
All right. Take care, brother.
Thank you.
Bye-bye. Bye-bye.
Thank you, sir.
Bye-bye. Bye-bye.